What? Hello, boys and girls of Calculus Land. Welcome to the wonderful world of Thailand. Swati Club? Kung maiเข้าใจภาษาไทยครับ My club? คุณไม่เข้าใจภาษาอังกฤษครับ Then we'll speak English, I guess. It's a pity we could have done the whole conversation in Thai because I'm fluent in Thai. Anyway, I just wanted to show you the wide, wonderful world of Thailand. There's a beautiful beach, but there's something even better. Look at this right here. These sticks have drifted out onto the ocean looking just like an X and a Y axis. Isn't that amazing, calculus people? Camera on me. It turns out I recently got a letter from one of the boys out there in Calculus Land named Aaron. Aaron, thank you so much for writing in. Aaron's question was this. Mr. Calculus Land teacher, if you happen to know the second derivative, isn't there some way you can tell if the original function f of x is increasing or decreasing? Let's find out. Camera person on the x and y axis. Let's say we have an f double prime, and let's say it's 6x. We'll make it easy, okay? 6x. There we go. And oh my goodness! Calculus Land, boys and girls, I have a palm frond in my hand that is a line. It could act like a line. It's linear. So let's just put 6x right there, okay? Now, you can all tell there's a point of inflection for f right here, right? Because guess what happens as the second derivative gets to 0? You see it going from negative to positive? So we know that f of x, is going from concave down to concave up, and we've got a POI right there, don't we? Now, the question is, can we look at this palm frond and say something about whether f of x is increasing or decreasing? The answer, camera on me, is no. And I'm going to show you why, just for this example, but it'll work for any other example too. Let's integrate f double prime, boys and girls. Let's integrate f double prime. Well, if we integrate it once, f prime of x, what do we get, boys and girls? Everybody say it together. That's right. 3x squared plus c. Plus c. And the c is the kicker. Because let's say that c is positive. Camera on me. Let's say that c is positive. Oh, and one other thing, camera person, always have the camera at the same angle. Don't ever hold it sideways, just always hold it long ways, okay? If c is oh my goodness, I have in my hand a palm frond that could be a parabola. So, let's say that this is 3x squared, and let's say that the c is positive. So that means, instead of having its vertex right at the origin, it would all be pushed up, whatever c is, right, like this. Now this is f prime. Can you look at f prime and say, is f increasing or decreasing? Well, sure. Well, sure you can. Because look at this. Is f prime ever negative? Don't look at its slope. Look at its actual y values. Is f prime ever negative? No. That means that this curve, the way we have it now, is always increasing. And it would look something like this. Be a little snake in the grass, kind of thing like that. Or it might look down here. You can't really tell, for sure. You can just know that it's always increasing. In fact, you might even say, it's camera on me, monotonically increasing. Now, let's say that that c over here, camera on over here, let's say that this c is negative. That means, camera over here, that means instead of our parabola being right here, it's going to be down here somewhere. This is f prime now. And now look at it. The thing is, can you tell that this will have a max right at this x value because your first derivative is going from positive to negative? And it will have a min right at this x value because your first derivative is going from negative to positive. Can you see that, boys and girls? Camera on me. We've worked on this, but I know it's been a while, so see if you can rewind it and watch that again if it's confusing. This graph is going to look something like this. Oh, and camera person, stand over here so that they can have the same perspective as me. It will look something like this. There will be a max right here, a point of inflection at 0, bam, bam. And this whole curve could be shifted up or down. Any of those would be fine. Well, look at these two curves, folks. Curve A and curve B come from the same second derivative. Curve A never is decreasing. Curve B does decrease and increase. So the answer, Aaron, eyes on me. The answer is that you can't actually tell from the second derivative if f is increasing or decreasing. It's that darn plus c. It's gonna get you every time. Now, before we wrap up our show today, we have a song I think that we all know. We all learned it in first grade. Let's sing it together. If you integrate a goat, you get a monkey. If you integrate a monkey, you get an emu. Now, emus can run, but they can't fly. And when they get dessert, they get mincemeat pie. Now, if you want to know the increasing, decreasing behavior of an emu, you can't go looking to the goat. You have to look at the monkey. The plus C is always going to get you if you try to look at the goat. But if you want to know the increasing, decreasing behavior of the monkey, then it's okay to look to the goat for that. And if you get the monkey to be positive, that will mean your emu is increasing. And you know what that means, boys and girls of calculus land? That means that your emu can fly. Thank you, everyone.